Hello, this is Professor Dan Kernler of Elgin Community College. This is another video in my statistics series. And in this video, we're going to talk about how to approximate statistics when we have data that are grouped together. All right, let's get started. We're going to start by talking about something called the weighted mean. I actually use this in my class to calculate my grade, so I'm going to use that as an example. This is the distribution that I use for my statistics classes, or something like this, where I have these different categories. So if we kind of look at them vertically, your grade gets stacked up and made out of these different components. So the total possible would be 100%, 15% from the understanding checks, 20% weekly practice, etc. So each of those components adds up to give you the total of 100% in the course. So what if we have a certain sample student, and this student has these particular grades at the end of the semester? The question is, what is their overall grade in the course? Well, that's where these weights come in. That's why this is called the weighted mean. So let's pull these categories over by their grades, and let's say, okay, so we have 10% of 71.6, or should I say 71.6% of 10%. So instead of a full 10% in that category, this student has 7.16%. So the 71.6% gets weighted by 10%. The 10% is the weight. Next category, similar idea, 85.7% of the 40% that was on exams, and then etc. For all the other categories, we have all their associated weights. You have their grades are the 71.6, 85.7, etc. And then the weights are the weights in the grading distribution. So then when we add all of those now weighted percentages up, we add those up, that gets 86.21%. That is the student's grade for the course. Here's how this would work. If we have the table, what we're going to do is we're going to add another column with the weight from the different category. That's what that category is weighted. And then we'll multiply them. We multiply the grade by the weight. We get then this weighted portion. We add all of those up and we get the 86.21% overall. This is called the weighted mean. So we could say X bar, the sample mean, with a subscript of weighted. And what it means is we add up all of the values times their weight. And we add all those up. That's the Greek letter sigma there for sum. And then we divide by the total weight. Now, in this particular case, the total weight was 100%. So we didn't end up dividing by anything because we would just be dividing by 1. But that is the weighted mean. Next, we're going to talk about what happens when you have data like this. This is income data provided by the US Census, but it's all grouped. So what if I want to find the average household income? All I have are these categories. How do I add them all up and divide by how many there are when all I have is groups and then the total within that group? If we look at these in table form, it's this long table with all these different classes. If we want to dive in on one, 25,000 to 29,999, it means there's 5,247,000. So that means 5,247,000. If we scroll down, look at another one between 70 and 74,999. There's 3,807,000 households there with incomes between those two. So here's what we're going to do. We're going to zoom in on this, and we're going to look at this first class, the 0 to 4,999. We have a couple of options here. What we're going to do, one of two options. We can either take the 0 to 4,999 and treat all of them as the average of those, $2,499.50. Another option is to do the first two lower limits, 0 and 5,000, and average those and call it 2,500. And that's honestly what most people do. So you can either average the lower and upper limits, or you can average consecutive lower limits. Either one is a reasonable option. Most people choose the latter. So if we do that for all of these, what we can do now is we can treat, instead of a range of values, we can treat all of those in that category as that middle value. So one problem we have here, though, if we scroll all the way down to the bottom down here, this bottom cell doesn't have a lower and upper, it just has a lower. So this is a little sidetrack here. This usually wouldn't be required, but this particular data is a little messy. we have to figure out what to do with that last cell. Here's a histogram of that, and you can see a clear right skew, but then there's this spike over here. What the heck do I do with that? That means it continues on, but it goes on a really long way. Household income is severely skewed right. If we think about the distribution shape, it looks something like this, and we have to know what would happen if that weren't there? What could we do for that last class if this were to continue? Now, there's actually a formula for this. Again, not something you'd normally have to do. It's a pretty funky formula. You have to calculate this index. You need a natural log in here. And then you find the mean of that last class, like what's the average of that last class, by calculating that index alpha over alpha minus 1. So it's a little messy, but just a formula, just plug some stuff in. It's not something that I'm super familiar with. I had to look this up to figure out what to do with group data. So if you want to make a note of this for that odd example that you might need sometime in the future, but we're just going to fill all those in, calculate that. So the index is about 1.89. Put that in for the alpha in the formula, calculate that. Oh, we need that lower class limit, 200,000, and so we get 423,651. That's what we're going to use then in that bottom cell as the mean for that particular category. So now when I look at all of these and kind of figure out what am I going to do to calculate the average for these, let's clean it up a little bit. What we're going to do is we're going to actually multiply all of these middle values and treat them all as 3,784,000 of those. So we're just going to multiply them all, find that product, and then add down all of those. So that'll be the sum of all the midpoints times the frequencies. And then we're going to do the same thing and find the total number, in this case, it'd be the total number of American households. And that's how we can approximate the mean from grouped data. We find all the midpoints, we multiply all the midpoints times the frequencies and add all those up and just divide by the total number of individuals. You can do the variance this way as well. It's a little messy. I'm just going to wave my hands at it. We don't really use it very often, but there it is. There's a formula for the approximating the sample variance from group data. But more often, people are interested in the mean. All right, so I'm going to finish this video by talking about this in Statcrunch. I'm going to walk you through this particular example. Finding an approximate mean from group data is actually pretty straightforward in Statcrunch. Usually, it's just this particular data, because of that last category, requires a little bit more work. So I'm going to do that, and then I'll catch you on the flip side. So calculating the weighted mean from group data in Statcrunch is pretty straightforward if you have the lower and upper limits like this. This particular data set is a little messy because of this last set. Now, we did calculate the midpoint, 423,651, but we need a lower and upper. So what we're going to do is I just got a Desmos calculator here, 423,651 minus 200,000. Okay, so that's 223,651. That's the distance from 200,000 to the midpoint. So what we want to do is we want to take 200,000 plus double that. That'll get us 647,302. So we're going to say 200,000 to 647,302. And then now it's as simple as stat, summary stats, and then we're going to choose grouped bin data. And our bins are the household income. And we do have counts. We have overall, we have black only, we have white only. We're going to do overall. And we talked about doing consecutive lower limits. We're just going to compute the mean, hit compute. And there we have the overall mean, weighted approximate mean from, this would be incomes for household income in 2019, $107,295.44. All right, that is it for this video. Don't be too overwhelmed about that last category and doing all that. Normally, for this particular type of example, we'd just be using the Statcrunch and using the grouped and bin data, and it's pretty straightforward. I hope you found this helpful. Hope you enjoyed it. If you want to see more of these and see them when they pop up, you can subscribe, hit the bell to get notified. I've got a whole series of these coming out. And also I want to take a moment to thank the Elgin Community College Board of Trustees. They approved my sabbatical for the spring 2021 semester, and that's when I was able to record all of these videos. So thank you so much for watching. Hope you enjoyed it, and I will see you on the next one.